lesson number 9 about solar energy. In this lesson, I'm going to explain solar inverters. A solar inverter is one of the most important elements of the solar electrical power system. Here we have the solar inverter. This is the solar inverter. It's convert the DC current comes from the batteries into AC current. And this AC current or this AC electricity then can be fed into your home to operate your appliances. There are 5 types of solar inverters. The first one is string inverters. We have the microinverters, hybrid solar inverters, central inverter, and battery-based inverter and charger. String inverters, multiple strings originating from the solar panel are attached to the inverters. For example, we have this inverter. So we have string 1 is attached to the inverter. At the same time, string 2 is attached to the same inverter. And the DC electricity produced in them are then transferred into AC current. So the inverter, we can see, change the DC current produced by the solar panels into AC current. And in this type, the string inverter, there is no batteries. The second type, it's microinverters. So microinverters installed for each panel to optimize each panel's power. We can see here, each panel contains its inverter. So the number of inverters is equal to the number of panels. So the transformation of the DC current to AC current happens in each inverter connected to each panel. So the output of the inverter here, the output is AC current. So what's the difference between the string inverter and microinverter? We can see here, in the string inverter, we use only one big inverter. But in the microinverter, we use a number of microinverters equal to the number of solar panels. Of course, microinverters are more expensive than the string inverter. But the microinverters solve the problem of the shading. We can see here when we have the problem of the shading. So in the first type, in the string inverters, the whole system will be reduced or the efficiency will be reduced to half because this solar panel is shaded and its efficiency is reduced to half. Okay, but in the second type, the microinverters, when one panel is shaded and it's reduced to half, we can see it will not affect the other panels. So there is an advantages according to the efficiency, as we can see here. So we can see the microinverters optimize the output power. We can see here optimize each panel's power in a module level. The third type is the hybrid solar inverter. In this type, we can see this type is multi-mode inverter. So what is the meaning of multi-mode inverter? This inverter, the hybrid inverter, do 3 jobs. The first one is take the charge, the DC current from the panels and store this electricity in the battery bank. At the same time, it's convert the DC current from the panel or from the batteries into AC current. So it's convert the DC current into AC current to supply our houses. At the same time, when the batteries are fully charged, so when the batteries are fully charged, it will take the excess power to the grid. So we can see here, the excess power can be sent back to the grid. So this is the grid. Okay, so when we have the batteries full charge, it will take the excess power to the grid. This type has 3 jobs. It's convert DC to AC and supply our houses, and at the same time it use to direct the DC current to the battery banks. Also, when the battery banks are fully charged, it will use to, and we have excess power, it can send back to the grid using this charger or this charge controller. The next type is the central inverter. In this type, it's like the string inverter. We can see the central inverter is like the string inverter. The difference is in the string inverter, as we can see here, the string inverter putting the string of panels into the inverter. Here we have a string of panels. This type, all the panels are connected to the same inverter directly. But in the central inverter, before we connect the panels to the inverter, as in the string inverter, in the second type, we use a combiner box. So all the strings of panels are connected to the combiner box first. So are connected together or joined together in the combiner box. And after the combiner box, they will connect to the central or one big inverter, or we can say to the central inverter. Of course, the central inverter is used with a large solar panel stations. So we can see here the strings are then connected to an inverter. So after the combiner box, the strings are connected to the inverter, which receives the DC electricity from the combiner box and then convert to AC. So here we have the DC, and we can see after the central inverter, we have the AC current, and then this AC is fed into the grid. The last type is the battery-based inverter. So this type has two functions, inverter and charger. So this type, as we can see, it's used to convert the DC current. Here we have the DC current. So it's used to convert the DC current into AC current. And also it can be used to take the AC current from the main grid or outsource generator. So it can take the AC current and save this AC current into a batteries after change the AC current into DC current. So it can be work as a charger at this part, convert the AC into DC and store this energy in this bank of batteries, or it can take the energy, a DC energy from the panel or from the batteries, and convert this DC energy into an AC energy or AC current. This type of inverter is a practical type, especially during the winter or during the shading problem. It is often difficult for the solar system to fully charge the battery. Of course, when we have during the winter or when we have shading, it is difficult to the system to fully charge the batteries. Hence, the inverter charger can recharge the batteries using AC supply. So we have two types of AC supplies. We can use outsourced generator, or we can take the AC current from the grid directly to the main panel, then to the inverter. This type of inverter is bi-directional, so it can work in both direction. So it can take the current from the batteries, so convert the DC current into AC current and supply our house, or it can take the AC current and convert it into DC current, which means that it can work both as a battery charger and an inverter. So here we have a review question about the lesson. Thank you.